So an interface is essentially it's a contract. So a software architect or an owner of the software company or whoever is responsible for designing code for clients will sit down with the client initially and try and tweak out what the client exactly wants. What kind of features do they want within their application? And those get specified within the interface. The interface will have a number of methods, and they don't have any implementation in them. They're just a number of signatures or statements within a class-like structure, which tells whoever's going to implement that later on exactly what's required within this project. So that's basically what an interface is. So we'll see an example of that on the next slide of what I mean. We'll look at a couple of design patterns that make use of interfaces. So they demonstrate the strength of interfaces and the kind of things that you can do. We'll also look at object factories. So a constructor is the way that we normally create objects, but you might want to have some kind of control over how those objects are created. So you create something called a factory method. So the factory imposes a set of conditions initially on whoever's using your class and only allows them to create objects if those conditions are met. Let's say you want to have a project for a telephone company. So within the interface is where you would specify what are the operations that I want. So for example, some of the operations I want are get the telephone number, charge a call, get the balance available on somebody's account, and you want to be able to credit the account as well, so add money to somebody's account so they can make calls. So within here, you specify the behavior that you want, but you don't want to actually implement any of the behavior. Where you want that implemented is somewhere down here. So these are the concrete classes, which have to, if they extend. So the contract is, if you've got a class and it extends an interface, if it implements an interface, then it has to implement every single method within that interface. And the idea is to have this clean separation between the design of the code and how it's actually implemented. Whoever looks at your project will look first at the interface. So they look at your interface and they say, okay, this library, if I use it, will allow me to do these operations. So that's why your interfaces have to be very well documented. So you need to describe exactly what your interface does and what each of the methods do as well. So the computer programmer will download your API, start using your interface, will create like something like this. So they'll do something like this. So phone account, P, and then they can use any of your methods. So using the interface, so they'll do something like p.get number, my wonderful handwriting, and they just use it, and they should be able to use it without having to look down here, okay, how it's getting implemented. So get number is well described within your interface, and people should be able just to use your interface without having to look at the implementation. So essentially, with most computer programs written in Java and written object-oriented programming languages, you end up with something that looks like this. So if you look at the Java libraries, the vast majority of them will have this structure. And this is kind of the structure that you want to aim for when you're writing your own computer programs. So you want to have an interface at the top where you define the contract or the exposed behavior, whatever it is you want the outside world to see. So that's contained within the interface. Essentially, it's just a list of methods with some good documentation telling the outside world what it is your computer program does. So this white bit here essentially is what a programmer that's using your computer program needs to understand. And that's all they need to understand. They shouldn't worry about anything that's happening here in the yellow zone. The yellow zone is your responsibility as the person providing this service, the person that's providing this computer program. So this is where, in the yellow zone, this is where you write the program, where you provide the contract, if you like. So the contract's defined in the white zone, and the implementation of the contract happens in the yellow zone. And within the yellow zone, you have a structure similar to the structure that we looked at in the previous part of the module. So you have an inheritance relationship where you put the common behavior in one class, and as you go down the hierarchy, so this is the simplest hierarchy that you can have. This is just 2 levels. You can have more levels if you want. So you put the common behavior at the higher levels, and as you go down the levels, the behavior of your program becomes more and more specialized. And the place where we usually put common behavior is using abstract classes. Okay, we have abstract implementation. We make use of abstract classes to do that. You can have normal classes there if you want the user of your program to be able to instantiate them and create objects of these particular types. But usually you don't want that. Usually the place where you have the common behavior is not a type of class that you want the user to instantiate. Usually it's just a placeholder for the code, for the common code of the classes that are below. Usually you want the user to instantiate objects of these types at the bottom here. You don't want them to instantiate an object of that type, usually. So an interface essentially defines a type and a contract. So when you create an interface, even though it has no implementation, you are providing a type which can be used. So for example, person can be an interface and he can do this. Person p is equal to new something. Okay, so you can do that. You are declaring a type. So it defines a type and a contract for the publicly exposed behavior of that type. A class that implements an interface, whether partially or completely, must adhere to the contract, which means that if I have a class that implements an interface, I have to adhere to its contract, which means that I need to provide all of the methods that are specified within the interface. I can't not implement one of the methods. I have to implement them all. The details of how the classes implement these methods are not specified by the interface, so the interface doesn't care how you implement any of the methods. It just wants you to implement them somehow, so it's up to you as a programmer how you do it. There are usually many ways to solve the same problem. Yeah, an interface may be implemented by many different implementation classes. So an example of that is the collections hierarchy within Java. So for collections, you have lots of different types of implementations. You've got things like array lists, for example. You've got sets. You've got, I don't think maps are part of the collection. But there are other things. So there are lots of different types of data structures that implement the collections interface. And they each do it in a different way to help solve different types of problems. Yeah, and a useful feature is that an implementation may implement more than one interface. So that's unlike in implementation inheritance. So in implementation inheritance that we looked at in the previous part of the module, you can only extend one class. Okay, but with interfaces, you can implement as many interfaces as you want, and by doing so, you acquire their behavior. Usually there'll be a primary interface. And so the primary interface is basically the normal is-a relationship. So for example, a student is a person, so that's your primary interface. So you'll be getting most of the methods from that interface, but optionally you can also implement other interfaces that provide orthogonal behavior or additional supporting behavior that might be useful to you. So that's another useful feature of interfaces. So here's an example of how an interface can be very, very useful. This is a data structure that exists within the Java libraries to do with drawing shapes and graphical kind of stuff. And within the Java libraries, you'll find there's an interface called shape. So that's there. And so that's just an interface. It has a list of methods, but there are no implementation of those methods because that's what an interface is. And you have a number of concrete implementations that implement the shape. So examples of those are rectangle 2D, ellipse 2D, and line 2D, and there might be others as well. And they each implement shape in different ways, obviously, because we're trying to draw different things. So shape will have a number of methods, and then each one of these will have to implement those exact methods, but they'll do them in a different way for their different shapes. And the usefulness of this data structure is in when you come to use it. An example of that also exists within the Java library. So the Java library's got it's an interface as well, I think, called graphics 2D. And one of the methods in graphics 2D is, for example, you've got draw shape and you've got fill shape. You can draw any shape and you can fill any shape, which means that you can pass into shape any object that implements the shape interface. And that's useful because now I can change the implementation of rectangle 2D. I can, any of the code in here, I can add more code. I can add to the codes, to the ellipse, to the line, and it doesn't affect how the code is written within Graphics 2D. So if you didn't have interfaces, you'd have to have a method for fill rectangle. You'd need to have another fill method for circle, another fill method for ellipse, another one for line. I don't know how you fill a line, but so you'd need to have a method for each one of those shapes. And if I added another shape, if I added another shape class here that's implemented interface, I would have to add another fill here for that particular shape, whatever it is. But by using an interface, I don't need to do that. It holds any object that implements it, basically. So interfaces insulate the users from the implementation details, and it decouples the interface from the implementation itself. So these are the benefits. Implementation of an application program as interface can evolve without disruption of existing users' APIs. So this is the example that I showed here. So this is a user here making use of the shape interface, and the user's code doesn't have to change. Okay, so I can evolve the code in here as much as I want, but then the user doesn't have to change anything within their own code. So you can defer decisions, so I can release my code to the outside world because I'm using interfaces, and you can start to use it, and I can defer decisions on any changes I want to make later. So I can change the implementation at any point in the future, and it's not going to break anybody else's code. So interfaces and interface inheritance are almost without qualification a good thing. So it's a design principle that you want to include in all of your computer programs, unlike implementation inheritance. So this is one where we could implement our university person, lecturer, student example that we looked at before. So this is another way we could implement it. Instead of having any code within my person class, I can just declare it as an interface. In this case, our getName and getAge methods won't have any code within them. So this is how you declare an interface. So it's exactly the same way that you would declare a class, but instead of using the class keyword, you would use the interface keyword here. So yeah, so in this case, what we've done, we've placed all the common behavior within the university person class, so abstract class. So we've implemented getName here, we've implemented getAge, and we've implemented getInstitution, all within the university person abstract class. Yeah, okay, and I presume that any specialized behavior then goes into the concrete classes below.